On Friday, I had to turn up my volume there. On Friday, we introduced the quadratic formula. So hopefully you've seen it before. If you haven't, there it is. So top left, there's a formula. You got to set your equation equal to 0. And this is based on this basic form of a quadratic equation. So if we have ax squared plus bx plus c equals 0, those coefficients, the number in front of the x squared, number in front of x, and the number by itself resemble a, b, and c. So the key to it is to move everything on one side and have it set equal to 0. So like if you look at number 6 right there, it's ready to go. It's set equal to 0. But number 7 is not. So on Friday, all we did was we worked number 7, and we moved on and worked a word problem. So let's give number 7 a try. It is not set equal to 0. So when I come over here to write what A is, what B is, and what C is, I don't know unless I do some mental math. But let's move everything over so we don't have to do mental math. I personally like A to be positive, so I'm going to leave the x squared term alone and move the other two to the left side. So keep that one there, subtract 2x, add 2, and we have equal to 0. The number in front of x squared is really a 1, b is a negative 2, and c is a 2. Then I look at the big formula up there, and by the way, that formula will work for any quadratic equation. So all week we've been factoring, square rooting both sides, completing the square. Those are other options to solving, but this quadratic formula will always work. For example, do you see the inside of the square root here? It's called the discriminant over here on the right. I'm not going to test you over that term, the discriminant, or any of that stuff that I typed right there, but it's kind of helpful to know what situation we're looking at. Because if that b squared minus 4ac gives us a negative, I know I'm going to have an I. I'm going to have imaginary answers. If I end up getting 0, that means I probably could have factored this thing and gone a lot faster. If it's greater than 0, then I might get some ugly numbers. It just really depends on what type of numbers are under there, perfect squares or not. So, all right, well, we're doing quadratic formula. So I'm going to plug into that big fraction. Notice it says opposite of b. So I write, this is the negative from the fraction, and then I do parentheses when I plug in. So I have a double negative. That's going to become a positive. Plus or minus b squared minus 4. A is 1 on this problem. And c is 2. This one's going to work out really nicely, unlike the word problem we're about to work. All over 2 times a, which is 1. So double negative gives me a positive 2, plus or minus. That looks like a 4 and a negative 8, all over 2. And then I get 2 plus or minus negative 4. And I hope we can all answer what square root of negative 4 is. We practiced it a week ago. Square root of 4 is easy, right? That's a 2. And because of the negative, we get an I. So I'm going to go sideways now. I'm running out of room. And all of those are divisible by 2. I'm allowed to divide all by 2, and I am left with just that. It's kind of like cross-canceling, or it is cross-canceling. Divide them all by 2, and I get 1s. Now, I am A-okay with that answer. You can just stop there, but some people get so confused by the plus minus thing. That means one answer is 1 plus I. Another answer is 1 minus I. Remember, this is quadratic. So because we have an x squared right here, that means we have 2 potential solutions. And naturally, you see it below. We have 2 answers, 1 plus I and 1 minus I. All right, let's try the word problem. All right, I printed this for everyone. Sorry, it's a little depressing. It's about car crashes. But the math is important to be able to do. So some data was taken from this insurance institute, and they did car crashes by age group. So that's real data right there. That's just over time. And then in the italicized sentence there, it defines some variables. N is the number of crashes, and X is the age. And they came up with this formula here to predict number of crashes based on your age. So the question is, what age groups are expected to be involved in 3 crashes? It says per 100 million miles driven. You don't have to do anything with that. Notice that's up here. So all of this is per 100 million miles driven. That's a lot of miles. So the big question is, what letter resembles 3? I'm going to change colors. And my pen is no longer working. There it goes. Do you think of it as an N or X? Look at the italicized sentence. It is N. So I plug 3 in. Now I have one variable. I have an X. And I can solve that. It's a quadratic situation. I have no idea how to factor that. I don't think it's factorable. I don't know how to square root both sides. I could complete the square, but that would be quite the headache. So let's just use the quadratic formula. If you're ever stumped and you don't know what method to use, quadratic formula will always work. We need to set it equal to 0, so let's move the 3 over. And now we are ready to go. On the side, write down what A is, what B is, and what C is. So A is in front of x squared. For some reason my pen is not working. There it goes. One of these days I'll get an Apple pencil and they say it's a little better. All right, A is in front of x squared. B is in front of x. Oh, and I forgot my x in that next line. So it's negative. And C is all by itself. So let's plug it into this monster here. Opposite of B. So I get a positive 1.19 plus minus negative 119 squared minus 4 times A times C. This step right here is where I see the most mistakes, especially when you have decimals. Take your time, look at what you wrote down, double check that it's all correct, you plugged in correctly. That negative b is where people mess up. And by negative b, I mean in the formula, it's negative b plus or minus b squared minus 4ac over 2a. And that very first term, negative b, people mess up on. Okay, type in the stuff under the radical. It's really handy if you have an Inspire. If you're using your phone, it's kind of difficult. But I get 0.10362 all over 0.026. Let's square root that, and I get another ugly number. I get 3219. And then I'm going to break it into two fractions. If you can do this in your head, go for it. But I'll write it out. So we add 3219 and divide by 026, and we subtract 3219. Remember that plus minus was just shorthand for two answers. And I get 58.15 and 33.39. So we can say, let's make it stand out with another color, about 58 and 33 years old. All right, that's question 1. Notice there's a second question. How well does the formula model the data in the graph? Remember, the graph is real, and this is just a model. That equation right there, that's just what some statistician came up with to predict crashes or predict ages. Or I think it's predicting crashes, sorry. You're using age to predict crashes. So take a mental picture of that 58 and 33. Scroll back up. Look for 3 or something close to it. And I see this bar. And I see this bar. And I don't know, it's not perfect. 33 and 58 are pretty close to that. Remember, it's never going to be perfect whenever you're estimating. So I would answer that last question. The model does a decent job. 33 and 58 are pretty close to 35 and 55. So you have to make sure you answer that question if it asks it on the test. All right. See y'all in class. Have a great weekend.